Good morning, everyone. Welcome to the talk Streamlit. Today, we will be covering the basic concepts of the module Streamlit, then take a look at some of its applications, and followed by the demos that I have built for you in the talk. So, let's get started. Before we begin, let me give you my brief introduction. I graduated from DICT with a BTech honors degree in Information and Communications Technology. Since then, I've been working as a software engineer and a data scientist at a company called Infocus Innovations Private Limited. Infocus is a consulting company providing ML solutions in various disciplines. To know more about Infocus and its work, please visit the website infocus.in. At Infocus, I have worked on various projects with top international clients in the domain of software engineering and machine learning. Please feel free to contact me using the details provided in the slide. Today in the talk, we'll be covering Introduction to Streamlit, where we'll be looking at why Streamlit was needed, followed by some of its main concepts and widgets and components that it provides to build web apps. And lastly, we will take a look at two of the demos that I have built for you in the talk. Now, as a developer, you all must have a question. Why was there a need for Streamlit? Well, we have an answer for that. The Streamlit inventors felt that there was no easy to use Python module to create web apps to present ML results or data or business insights. To make it more easier for you, let's take a look at some of the alternatives and the difficulties associated with it. The first and the foremost option is Jupyter Notebook. Now, as an ML researcher, engineer, or data scientist, you all must have come across Jupyter Notebook and must have used it extensively. But it is not a good way to deploy it in production. The next option is Dash by Plotly. Well, I would recommend this option if you would like to build an aesthetic looking web app. But the only downside is that the developer needs to have a prerequisite knowledge of HTML and CSS. The last and the most preferred option that I have seen being deployed in production is the use of Flask framework. Now, there are many layers of abstraction associated with the Flask framework, and hence it becomes complex to use for the developer. Well, this justifies that there was a need to invent Streamlit. Now, let's take a look at some of the applications where Streamlit can be used. In the first video, we will be taking a look at the data analysis app where we'll be visualizing the data of Uber pickups in New York City. So you can see this web app. As we scroll down further, there is a checkbox, and clicking on that, we get a tabular form of data, which denotes the date and time of the pickup as well as the location of the pickup represented by latitude and longitude. Now, if we go further up in the web app, we can see a slider wherein the user can select an hour from the 24-hour range. Once the user selects the hour, the user can see the heat map of Uber pickups in New York City. And if we scroll down further, we see a histogram of Uber pickups for that particular hour, for each minute in that hour. So we looked at a data analysis web app built using Streamlit for Uber pickups in New York City. Now let's take a look at another application where Streamlit is used. In this application, we will be taking a look at the model inference of object detection model called YOLO v3. In this web app, we are basically have the trained YOLO v3 model, and we are asking that trained YOLO v3 model to detect objects from the frames in the video. Now, as you can see here, I'm selecting car from the drop-down option and asking the trained model to detect cars from frames in the video. Using the slider that I just clicked on, I'm choosing the frame number in the video that I would like the trained model to detect cars in. And now, as you can see, there are many sliders in the sidebar, which are the hyperparameters of the model, and the user can play around with it and see how the output of the model changes with the change in the hyperparameters. So now that we have looked at some of the applications where Streamlit can be used, let's move on to some of its basic concepts. The first concept is it embraces Python scripting or pure Python app in their terms. So what this means is you just need to write a simple Python script and you would have your web app built using Streamlit. So this is same as writing a Python script for any other purpose that you would be developing. The second concept is immediate and interactive live environment. The Streamlit provides various widgets and components through which it makes the web app more user friendly and interactive. Regarding the immediate environment, whenever developer changes something in the code of the web app, he or she can immediately take the look in the browser UI and see the immediate effect of that change. The last concept is it re-executes the script top to bottom whenever something changes in the app. So what it means is whenever the developer changes something in the code of the web app or when the user interacts with the web app, Streamlit will execute the whole script in a top to bottom manner. Now, there must be a natural question that would come to your mind. Wouldn't that slow down the rendering of the app? And I would say that is a valid question. But Streamlit has got it covered. Streamlit provides the functionality through which it renders the web app faster. Can you guess it? To give you a hint, it is a simple term that everyone must have heard during his or her education in computer science field. Yes, the answer is caching. Streamlit provides the functionality of caching so that the developer can skip the redundant data loading and fetching part or even the heavy computation part associated with the web app. By using the functionality, we can render the web app faster. Streamlit also provides this functionality in the Pythonic way of using a decorator. So if you know what a decorator is and how to use a decorator, you just need to write at st.cache on top of the function that you would like to get it cache. But before we take a look at how we can use the functionality of caching, the developer needs to keep some of the conditions in mind. So let's take a look at some of these conditions. And to better understand these conditions, let's take a help of an example code snippet. Now, if we take a look at this example code snippet, we see that we are trying to cache the function called compute exponent. We take a look at the first condition. It says input parameters passed to the function. Now, as you can see in the code snippet, we are calling the function compute exponent in the last second line with the parameters a and b. So that becomes the input parameters passed to the function. Now, if the value of those parameters doesn't change throughout the course of the web app, Streamlit would use the cached version of the function compute exponent in the subsequent runs. The second condition is value of external variable used in the function. Now, if we take a look at the body definition of the function compute exponent, which we are trying to cache, we see that there is an external variable called exponent. Now, if the value of variable exponent doesn't change, then Streamlit will use the cached version of function compute exponent. Otherwise, it will not use the cached version of the function compute exponent. Next condition is the body of the function. So what it means is if we check the body definition of the function compute exponent, if it doesn't change, then Streamlit will use the cached version of the function in the subsequent run. The last condition is body of any function used within the cached function. So if we take a look at this code snippet, we see that we are calling an external function called multiply in the compute exponent. So if the body of the function multiply changes, then Streamlit won't be able to use the functionality of caching in the subsequent run. Now that we have looked at some of the basic concepts, let's take a look at the widgets and components that the Streamlit provides to create web apps. As a developer, you need to flush out various forms of data to your web app. Now, whether you need to flush out text data, tabular data, data frames, graphs, image, plots, anything, you can just call a single function st.write and you will achieve your purpose. Now, those who have used Jupyter Notebook must be familiar with the Markdown. Well, Streamlit also supports the Markdown functionality, and the user can use it by calling the function st.markdown. For all the math enthusiasts and ML researchers and engineers who would like to include a table or mathematical equations in the web app, well, Streamlit has covered it all for you. So you just need to call the function st.latex if you want to include LaTeX functions in the web app. Now let's take a look at some of the widgets which makes the web app more user friendly and interactive. The first is the text input. Text input is like a text box where the user can type anything. For example, where we have a web app, we ask a question to the user. Then the end user can type in anything for his or her answer in that text box. Second is the slider. As we have seen in the videos earlier, slider is a widget where the user can select a value between minimum and maximum range provided by the developer. Next widget is checkbox. Checkbox is like an on and off switch, which allows the developer to execute a piece of code based on a condition. The last widget that we will be covering is the select box. Select, select box is essentially a drop down option. Drop down options can be of two types: single value drop down and multiple value drop down. The developer needs to make sure that he or she includes this widget so that it makes the web app more user friendly and interactive. The last component that we will be looking in the talk is the sidebar utility. Now, you would have a question: why was there a need for sidebar utility? The Streamlit inventors felt that we need to give the end user a more cleaner look so that they focus on the main output and the result of the web app instead of focusing on the widgets and the components of the web app. And hence, they invented the sidebar utility. So, as we have seen earlier in the application video, we saw that all the widgets were placed in the sidebar utility. And this allows in getting a cleaner and focused look for the end user. Now that we have covered the concepts and components that the Streamlit provides, let's install Streamlit. To install Streamlit, you need to install pip first. After you have pip installed, you need to just call a single command: pip install Streamlit. The only requirement is that it requires Python 3.6 or higher. Once it is installed, you can run the command streamlit hello and check if everything's working fine. That will open a tab in your browser and it has many beautiful inbuilt demos that you can play around with. All the resources for this talk can be found at this Git repo. Please check that out and let me know if you have any questions or issues associated with it. We will take a look at some of the demos that I have built for you in the talk. So as you can see here, I have a web app built where I have plotted the ticker closing price for the New York Stock Exchange. So as we can see here is a checkbox. Like if I untick it, we do not see the tabular data frame. But when I click it, we see the tabular form of data where we have a record for each date corresponding to a ticker and various prices associated with it. Below that, we have a drop-down menu where we have selected SPY and Apple tickers from the New York Stock Exchange. Now let me edit here and we can see how the output changes rapidly. So this is a web app that shows us how to plot the closing price for the ticker in the New York Stock Exchange. Now let's take a look at another web app where we have an iris prediction, flower type prediction app. So this app basically has the user defined inputs for the features and it would use a decision tree classifier to output the predicted type of the flower. As you can see here, there is a sidebar utility where we have four features and corresponding sliders for that. So the end user can play around with those sliders and select the value of the features and check what is the output of the predicted flower type. So let us try to play around with that. So now as you can see that we have a change in result for the predicted type. Now here we can see that we have a tabular form of values for the features that the user has selected, and below that we have the class predicted by the model using the features that are provided by the user. So these are the two demos that I have prepared for you in the talk. Please refer to these resources for advancing your knowledge in Streamlit. If you face any troubles or issues, please contact me using the information that was provided earlier. Thank you.